Okay, so let's talk a little bit about mocks. Because I indeed saw many questions about mocking appearing in this last week, and right now you're asking me about it. So suppose this piece of coding here. Okay, so this is the Christmas discount class that you have also in MATLAB. It receives a clock, and it has this apply discount method. That's the one we want to test. And what you get as a tester, if you look at this, is I need to instantiate this class. This class has a dependency, so I have two options. The first option is to pass a concrete instance of that class, and the second option is to simulate it. We discussed the advantages and disadvantages of simulating a dependency, right? And one of them is that if you simulate a dependency, you have full control. And this seems perfect for this situation because this dependency is a clock dependency, which basically gives me the current date and time. And it's just pretty hard to try different date and times if you don't simulate, right? So then as a tester, I know that I will have to mock this. Then let's focus on the main method that I want to mock. So I know that the now method is invoked. So this means as a tester, this is what I will have to teach my mock what to do. So in this case, return some date, right? That is used in the rest of the problem. As a tester, I see that it gets the date, the day, and the month. And if it's Christmas, it sets this Boolean to true. This Boolean is used here. So as a tester, I know that I need to exercise this as true and false to get some sort of coverage here. I also have this inline condition here. So maybe I want to exercise some condition there to make sure I tested all the possible combinations. And it just returns some math. So as a tester, that's what I need to do. So then let's first focus on the mocking part of the problem and not on the testing part of the problem. Because the testing part of the problem, you can just do domain testing, right? You have Christmas and you have not Christmas. Maybe these two are enough to achieve to do some domain testing. So that's what we do. So let me write this code in a simpler way so that we don't get so confused. Let me hide this from you. That's my first test. What I need to do is to create a class I want to test. So Christmas discount refactored. We were talking about IntelliJ shortcuts. That's another one that I use. So you see that I just wrote some initials, like Chris did R, and then IntelliJ detects this, right? So I create it. IntelliJ tells me that I need to pass a clock. Great, so I just put clock here. And I assign it to a variable. I'm gonna call it CD. Yeah, just Christmas discount. I know that clock needs to be a mock because I want to fully control it. And that's what I do. I use mockito.mock, and then I create a mock of the clock class. That's just the Mockito syntax, and you just have to memorize it. And that is the clock. Yeah? Great. Next thing I need to do before invoking the method I want to test is to teach the mock what to do. And this answers the question that I saw in the chat. When do I use the when? I use the when I want to set up or to teach the mock what it will do later. So in this case, if I look to the production code, I see that the now method is the one invoked for the clock, right? So this is the method I need to teach. So when, and then I just write the name of the method. So clock, well, it's my mock, then the method, then return the Christmas date. And in here, I just created a Christmas date, right? I know that the method now, we can actually look at the interface. The method now returns a calendar. So in here, I have to put a calendar, and that's what I did. And because in this test, I want to try Christmas, I just create a date that matches Christmas. So any year, it doesn't matter, December 25. So my mock knows what to do if we call clock.now. maybe a nice way for you to see this happening is, let me just comment everything else. And what I am going to do is I am going to print the mock. So I'm gonna call clock.now in my test just to see the mocks working, okay? So if I run this, compiling, compiling, compiling. This is a very bad test because I don't have assertions, right? So we should never write tests without assertions, but maybe enough for us to see. So you see this clock.now prints something. It prints the toString of the calendar that came back to us. If I can, yeah, maybe if I do it like this, return it calendar. Yeah, maybe that's more explicit. So clock.now returns a calendar, and I just printed it. And if I look for the day here, that must be somewhere. So year 2015, month December. So internally, calendar took this very bad decision that January is 0, so December is 11. You can actually see, if you inspect the value of this constant, you see 11. Very bad decision of Java calendar. And then day of the month, 25. So you see the mock returns what I just taught the mock to do. Yeah. But of course, I don't want to call the mock in my test code, right? The mock will be called by the production code. So let's do like this. Oops, let me just import this. So I call the method I want to test. I pass any amount, so 100. And when I invoke this method, this will be executed, right? Clock.now, but who is clock? Clock is the mock. Maybe another also way to slowly see this is if I debug. So I'm gonna run my test in debugging mode. I'm not sure if you learned how to use the debug mode before, maybe in introduction in OOP first quarter. But the debugging mode just lets me go step by step in my code. So the debugger is stopped here, and I will tell the debugger to then go inside of this method. So what I'm gonna do is, let me do this via the menu so you can see the option. Where is it? Debugging actions, and then step into. So it basically says, let's go inside of the method. So I was here, then I went here, which is just my program, going step by step. And then this line is here, clock.now. You see the description here, mock for clock. So this is how Mockito internally shows for you that this is a mock. If I go to the next line, so this means this method returns something. If I look at this today, I'm not sure if you can see this, so let me do this in another way. Do you see the pop-up? Great. So this is basically telling me what today is. And today should be, let's see, maybe here, no, maybe here. Where do I see the internal date in here the same way we saw before? Okay, so I am going to, let me see if I still remember some old Java. Let's see if that works. No, it's another method. So I just wrote some ugly Java here just to see what comes out. So 25 December 2015, right? So this was all to show to you that the mock returned indeed what we wanted it to return. Yeah. So because it's Christmas, inside of the value, this expression is Christmas will be evaluated to true. So if I inspect it, it is true. Okay. I can just continue and my test will now pass. Yeah. No. So as a tester, when using mocks, this is what you need to know, right? So you look at the production code, you see what needs to be mocked. In this case, I could see it's this now method. So in my test, I just mock it. And by mocking it, I mean, I declare my mock, and then I use this when thing from Mockito to teach the mock what to do. If I wanted to do the other test for the no Christmas, basically the same piece of code, I create a mock, I instantiate the class, and I pass the mock. Right, so let's even rename this variable to mocked clock. And then I just pass a different date to this one. Yeah, so 24 now, so it's not Christmas. And if we then execute the method, what we know is if it's not Christmas, there's no discount, right? It only gives the discount if it's Christmas. So this means if I pass 100, I should get back also 100 here. Let me run both. So both of them pass. Okay. So this was the Christmas example. And this one was an example of a stub, right? So this was not a mock per se. Usually when you're doing mocks, so the philosophy, right? You use Mockito for both, for stubs and mocks. But when you're doing mocks, at the end of your test, you want to do some assertions on the mock. And that's usually by means of the verify method. Yeah. In here, we didn't verify anything. So we just kind of explain it to this clock mock that it needs to return some dates whenever the method now is invoked. But we didn't kind of care about the interaction with this mock. So this was a stub. Yeah. However, for some other problems, you may want to check the interaction with the object. And that was the case of the other problem that we had there, which was, for example, the invoice filter test. Let me open the production code. Let me see if it's this one. No, not this one. Yeah, for example, this one, the SAP invoice sender. So you, as a developer, you wrote this class, and this class is beautifully designed. It's really small. All the dependencies come via the constructor. So this is actually a good design decision. So this class is very nice, but how do you test it? Well, let's see the main method, right? What do we want to test? We want to test this. This is the main method of this class. What does it do? It gets the low value invoices, and this comes from a filter. And then it applies to all the invoices that come back from this. It applies this sap.send. So it sends to the SAP. As a tester, again, you have two possibilities. One is to do integration testing, right? So then you could create this SAP invoice sender class and pass a real invoice filter, and you pass a real SAP dependency, but this comes with a cost because maybe communicating to the SAP is too expensive. It takes too much time. The invoice filter maybe really goes to the database, and then you also don't want to set up a database just to make sure that all of them, all the invoices are passed to the SAP. So what you can do in this type of problems is to do what we call interaction testing. which is to just make sure that the interaction between your objects work well. What interactions do I see here? I see that all the methods that come from this filter are passed to this SAP send. To facilitate my explanation, I'm going to rewrite this in a more plain old Java. Okay, so this low filter invoices return a list of invoices. Okay, and then what I do is for each invoice, I pass it to the SAP. Okay, so same thing, but just now written with old Java. So what interaction do I see here? I see that all the elements of this list are passed to this SAP thing. So this is what I can test. How did I do this? Let's see, straight to the solution. So let's also simplify this code to make things easier to understand, okay? That's what you can do at the beginning. Just write a very ugly, long test method. When you're sure that everything works, you then refactor. That's what I do. I never start my tests by writing fields and etc. These are, you know, these perfumes I put usually later when my implementation works, okay? So in that sense, I would not have this at the beginning. So I know that I want to test this in SAP invoice sender, right? What it needs? It needs a filter and it needs an SAP. So this returns the sender to me. Yeah, let's give some info here. I decided that I'm going to do interaction testing, which is I'm going to use mocks and then later ask my mock if the interaction was as I wanted it to be. So first thing is to create the mocks. So let's create a mock for the SAP. Mockito.mock SAP.class. Let's create one for the filter. Mockito.mock invoice filter. Great. So I created my mocks. I created a class I want to test and I passed all the mocks to this variable. Let's even give proper names. So filter mock and SAP mock. And now I do have to teach these mocks to do something, right? So let's see, what do we need to teach them? I go back to the source code and I see that I need to teach these low value invoices to return something. Yeah, a list of invoices, that's what I need. So that's what I'm gonna do. So I will create a bunch of invoices. Let's remove this final from here to not complicate too much. How many? Let's suppose that I'm just creating 3 invoices here. Yeah. So for me, for Steve, and for Adi. And I teach the mock to return something. How do I do this? Again, with the when function from Mockito. So mockito.when. When the mock.lowValue invoices is called, then return a list of invoices. Okay, again, just to simplify, I'm extracting things just to make it more explicit. I create invoices, I put them on a list. This is what this arrays.slist is doing here. Yeah. Another way to see these, maybe if you're not familiar with this arrays as list, you could manually create an array list. And then list.add the invoice from Mauricio, the one from Steve, the one from Adi. Yeah. Simplifying the Java code in here just to make sure we are all on the same page. Okay, folks. Let me give the same name here. So this is the list of invoices. I didn't use IntelliJ to rename, and then I had to do more work. That's why you should know IntelliJ shortcuts. So I create a list of invoices, I add them all, And then I just teach my mock. When this happens, returns this. Maybe I didn't say this before, but I know that the Mockito syntax can be quite tricky if you're not really familiar with Java so much, because it's really strange to invoke a method like this, and it just looks strange. But what you need to know is when you call the when, you just pass then the method you want to mock. Once you get familiar with this, this looks really beautiful to your eyes. I can assure you of this. Okay, so I teach the mock to do something when this low value invoices is invoked. I go back to the code to learn, and then I say that the SAP, I don't need to teach it to do anything, right? Because it doesn't return anything. Just the send method is called. So then I call the method under test, send low valued invoices. So this means my test came here, executed this entire program, and came back. So now time for the assertions. What assertions do I need to do? I will assert that the SAP received the 3 invoices we passed to it. So in this sense, let me remove this one. So what I'm saying is SAP verify that the SAP, the send method was called with Mauricio, with Steve, and with Ali. Yeah. So see, I'm testing the interaction. I'm testing that the SAP object was called in the right way. And that's what I expect, right? Because there will be 3 invoices here. So it will be sap.send, and then invoice will be the first invoice there, so the one for me, then again to Steve, and then again to Ari. And that's what we are asserting in here. These times here is just a syntax sugar to say this send method should be called just once, not 2 times. Why is this important? Let me just run this test to show that this gets green. Yeah, great. So the test is passing because those things happen in the way we want. But let's suppose that the developer made a very simple mistake that was to duplicate this. So now the invoice goes to the SAP 2 times because of a logic error. If you run the program, the mock now will fail because the interactions don't match. Right? We are saying here that we just expect this SAP mock.send being called just 1 time for Mauricio, but now it's called 2 times. And that's what IntelliJ tells me, or Mockito tells me. So I wanted it to be just 1 time, but it was 2 times. Okay? So that's the beauty of interaction testing, because you can capture those things. Let me fix the bug. Then at some point I saw a question, what is never? So never is basically times 0. Yeah? Maybe you want to ensure that something is never invoked. Let me do a small change in this code and you're gonna see. So let's suppose we have one more rule here. That is if invoice dot value. Let me see how this works. No getters here. Let me create a quick getter for the value. So I will only send it to the SAP if it's smaller than 100. Okay? Let's suppose this is the new rule. As a tester, I feel the need to exercise then this if as being true and as being false. And that's what we have here. So we have 300, we have 99, and we have 20. So if those 3 invoices are now in this list, at the end, I expect that for Mauricio, it will be executed 1 time, because this is 20 is smaller than 100. Also 1 time for Steve, because 99 is smaller than 100. But for Ari, the method should not be called, right? Because this is 300 here. How can I ensure that? I can put times 0 there. So if I run this, I expect the test to pass, because now we are not going to call the method to the Ari's invoice, and we assert that as well. And this times 0 here is basically the same as doing Mockito never. So it's just an alias, you know, because Mockito people, they have this philosophy that it should look like something that you can read. So times 0, maybe it's easier to read if it says never. Maybe let's see behind the scenes. Yeah, you see behind the scenes is just times 0. So this is just syntax sugar for you as a developer to read it better. Yeah. So this is what mocks are about. Of course, in here, I didn't exercise domain testing the way we did in the first part. And that's what you do, right? So as a tester, you look at this and then you think, well, this is the main thing that I need to explore, right? So invoices that are greater than, if I were to do some domain testing here, well, there's just one variable that we care about, which is the value of the invoice. So we have the list of invoices, right? Which is just a list of invoice. And then we do care about the value of the invoice that is inside, right? So let's do this analysis later. And then if I do the equivalence table, equivalence analysis, we first have the list, right? Let me call it list. And then, well, this list can be null. That's what I would exercise. This list could be empty. And this list can have, because it's a list, I usually like to try one element and many elements. And then we need to exercise the content of the invoice, right? So what I would do is something like list, and then the type of the invoices or something like that. And then I would have, I know that I need to have one invoice that is smaller than 100, something like this, greater than 100. We do have a boundary, right? That is the 100 there. And those were what I would kind of use as information to derive the tests, right? So I would have one for smaller than 100, one for bigger than 100, and one for the boundary. Yeah, and then once you do this, and of course in the exam you are more careful with explaining everything that you wrote in here. So I was really quick just to illustrate what you would do. But once you devise the tests, then you just use mocks, right? To pass the data you want to pass to the program, yeah, so that you exercise everything that you want to exercise. So again, to try to generalize what I just explained it to you, you use mocks when you want to simulate the dependency. The first way, and let's separate this between stubs and mocks. When we're just stubbing things, I just care about giving values to these mocks, to teach these mocks to do something. And I just do this because I need the mock to return something so that my program continues and I can do some assertion that I want at the end, which was precisely the case of this Christmas problem. I just need my stub to return Christmas or not Christmas so that I can assert the final value of the discount, yeah? So again, the stub was just helping me to pass some value there. However, sometimes you want to use mocks because what you want to do is not just to return stuff, but to check the interaction that you have with that object. And this was perfect for this type of problems, for this one in particular, where we just wanted to make sure that the SAP was receiving the right invoices. So actually, in this piece of code, what we can say is that the SAP is a mock, right? Because I'm later checking the interaction with that mock. But the invoice filter is just a simple stub because I only care that it returns stuff so that my program continues. Yeah. So this is the difference. Let me open the chat. Wow. There's a lot of stuff there. Let me roll back a lot. I see a question about transition tree that I can answer later. There was one question about WebLab. I'll get there. Let me just focus on the mock ones. Interesting. I saw a question saying, how should we make tests for classes that use external data? Because in this SAP invoice sender, when I create a class, I get an error that SAP does not exist. That is possible, and this means this SAP class is not available in your environment. So you have to copy it from WebLab to your IDE. Tomorrow, I will give you a problem like this and many classes, and what you need to do is to copy those classes to your IntelliJ, right? If IntelliJ doesn't find the SAP class, it's because it's not there. So you're gonna copy from WebLab in your IntelliJ. It's gonna be something like this. Let me give an example. So in WebLab, I am going to give you, for example, these two classes. Something like this. Yeah. Of course, WebLab will put colors on stuff, so it's easy to see the differences. I also say something like, for example, this is the class invoice filter, and this is the class SAP, and they don't have packages. Okay. So this is what I give you in the exercise. What you need to do is to copy from WebLab, that is now represented by my Sublime, to IntelliJ. How do you do that? So the first one is called invoice filter, right? So you're going to go to this Java, source main Java that you have in your skeleton, command N to create a new class. You select Java class, and you type the name of the class. In this case, it was invoice filter. And then you simply copy everything there. Everything, just replace. Yeah. Then you're going to do the same for the other classes. So this one calls SAP. I'm going to do the same, class SAP, and then I copy the content. Yeah. If you just do this for all the classes that I give to you, this SAP class will be available in the environment for you. Yeah. In here, it's complaining that I have to copy the invoice class as well. But in the exam, all the classes will be there, and that's what you need to do. Just copy and paste to your IntelliJ. Again, source main Java. You can do file new Java class. You give the name of the class. So blah, blah. And then you just paste whatever we give to you in MATLAB. You're going to see it's very simple. It's just copying and pasting. Let me delete to make sure everything compiles in here. But that's how you ensure that things work. Okay. So in the exam, this will be as part of the question. We will give you all the classes you have to copy as part of the question. Let me see what else. There was a question on IntelliJ on how I rename variables. You can, if you never know where things are, you go to the refactor menu and you have many options in here. Okay, and this one was rename variable. That must be somewhere. Yeah, here rename. And then you can just rename. Okay, like this. IntelliJ was very smart. It noticed that I renamed this, and this matches with the name of the constructor. So if I select this, it will even rename here in the constructor. So it's pretty smart. Do I have to use final? What's the difference? What difference does it make? Good question. This is more related to the Java language rather than testing. If you put the variable as final, you're ensuring that no one can change the content of the variable later. That might be a good thing when you're developing. That's not something I'm going to dive into in this course. So you don't have to put final, okay? Let me see. There was a discussion about coverage, and that's a good question. But what you need to see is your notion of coverage doesn't change because you're using mocks, right? Our focus is still to test this method, right? Or in the case of the Christmas example, to cover the Christmas method, and you still apply the same techniques that we studied in the structural testing chapter. So you got to exercise this branch as true and false if we're looking for branch coverage, right? And the same for this. You want to exercise this as true and false. In this case, of course, because the way I programmed, so if this is true, this is also true, right? We could actually just do this in one line, something like this, that would work. So if you're aiming for branch coverage, for example, you just need to make sure that this is true one time, and this is true, this is false one time as well. So the notion of coverage is still the same. So in the exam, if I ask you to achieve branch coverage using mocks, that's what you need to do. Just go to the production code or the method you need to test and aim for the coverage. There was also a question about mocks. Do we need to check for verify no more interactions? Great question. So Mockito allows you to do something like this. So we made sure that SAP mock was called for Mauricio, for Steve, but it was not called for Ari. Those were very specific assertions, but maybe I'm on a place where the interactions are more complex and I cannot really see everything that is happening. So one possible assertion in Mockito is to say, you know, I asserted for those 3 interactions, and those are the only 3 interactions that should happen. I do not expect any other interactions. So Mockito, if anything happens that is not in these assertions, fail the test. And that we can do by this verify no more interactions. And then you pass the mock. Yeah? So those 3 Mockito will understand, but if anything happens besides those 3, Mockito will fail. Should I do this or not? It really depends, right? So in this case, for example, I would argue we don't need, because first of all, this implementation is quite small. Second of all, I can see that the interaction here is always related to the invoices that I pass. And this means I can be very precise in my assertions. So these 3 are enough to give me confidence that the interaction was as I expected. Is this verification what makes a true mock as opposed to a stub? Yes, exactly. So an easy way to see if it's a mock or a stub is usually in mocks, you do verifications. You care about the interactions. In stubs, you only care about it returning something, okay? In the for each but last exercise, you use never to make sure that the loop has ended, which is the same as verify no more interactions. Yes, in that exercise, let me see if I have it here. No, I don't have it here. Let me open this in a separate place. I'll show something in my screen very soon. So we had this method there to test, right? So for each but last. And the name says it all, right? So it basically does a for each in all elements of the loop, with the exception of the last element, right? So definitely the partition you should not miss in here is if I give a list with n elements, the closure should be invoked for all elements but the last one. And this is probably what I do in the answer here. So let's see. So for each but less with multiple elements, so if we pass 1, 2, 3, so the list has 3 elements, I expect the mock to execute for 1, I expect the mock to execute for 2, I expect the mock to never execute for 3. And then I assert that, because this method returns something, which is the last element, and I assert that the element is the same. So I'm mixing here interaction testing, because I'm testing the interaction with the object, with the closure, right? And I also assert the return of the method. Could I have used verify no more interactions? I could have. So let me just copy this test here. I could have, for example, instead of doing this, I could have done mockito.verify no more interactions, and I pass them off. That could be an option. That is more personal, right? So what do you prefer to read as a tester? Do you think this is more informative to you? Because then as a person you read verify that never execute 3, or verify no more interactions. It really depends. This is personal taste, and then it's more up to you. I usually try to be more specific, like this one, right? So never execute 3, and 3 is here, so this kind of gives me extra information. But again, more of a personal thing, okay? Can I show how to move the web lab mock exercises with library code? Yes, I can definitely do a more real example with the skeleton. Maybe that's a good thing to do. Let me do this in a second. Could I prevent the code duplication in the verify lines in case you test a large amount of invoices? Or is this not achievable with a parameterized test? Good question. So let's think what we could do here if we want to use a parameterized test. So let's roll back a bit. So usually one approach that you can do is you extract your set of verifies to a private method. Yeah. So that's usually an easy refactoring that you can do to improve the quality of your test code. In this particular example, this doesn't seem like it's going to work, right? Because those verifies are very specific to the data that I have in here, right? But nothing would prevent you from coming up with a method like, let's just explore to see if it makes sense. It's mentors. I could create a method that is something like this: verify interactions or something, and I'm going to pass a list of invoices that interaction is expected, and a list of invoice that interaction not expected. Then what I would do is a for each in this list. Let me do the normal for, and then for these ones, I expect mockito.verify. Ooh, I also need the mock here. That's great. So let me pass the SAP. So for all the invoices that is in this interaction expected, I verify times 1. Yeah, and I do the same for the other lists. Verify never, and I import from Mockito. Yeah. So that could be a kind of a helper method that you create to the assertion. This means then, for this example, maybe it doesn't make sense because again, it's too simplistic, but how I would use this, it would have to be something like this, right? So we pass this SAP mock, and then we pass the list of things that are expected. So in this case, it's Mauricio and Steve, and not expected is Ari. We can even use remove the erase dot to make it shorter. So I just add the static import. And that could be one refactoring that you do if you then move to parameterized tests, because I can see some like generator. Where, for example, your arguments is something like the full list, and then you pass the expected invoices and the non-expected invoices, you know, something like that. So that can be one way to think about this in this exercise or in this problem. So, and to be honest, I do tend to create those verify methods, because sometimes the interaction between objects are too complex, and then if you just put them into a private method, things get clearer. That being said, again, for this particular example, because achieving coverage is not so complicated because it's a small problem, I think instead of going for parameterized tests, I would have 2 or 3 test methods, and I would put the assertions there. Yeah. So maybe it would be a little bit of repetition between them. I would try as much as possible to, of course, extract those repetitions to maybe fields like I had here before and these kind of things. But maybe that's just simpler to understand than a parameterized test that is too long or too complicated. Let me see. It's been hard for me to catch up with all the messages. Is there a good example of structural testing for the exam? Well, all the questions from the domain testing, right? So all of those are snippets of real open source systems. And what you need to do is just choose one of them and think and achieve 100% branch plus condition coverage in there. If you repeat this, then you definitely understand structural testing, right? That's the goal. Look at the source code and come up with test cases that achieve some coverage. Maybe my IntelliJ doesn't seem to know Mockito. Does anyone know how to fix this? If you're using the skeleton, this should work for you. So are you using the skeleton? I will open the skeleton here, and then I can show you some workarounds that you can try. Do you need to do a second clean skeleton? No, just use the same, right? Because you're not going to write a lot of code. So the same skeleton you had before, you can still use it. I see also a question in the chat. Maybe I said this before, but does anyone know why I didn't test for no invoices or more than 1 invoices? That's what you need to definitely test. This question is from Vivian. So Vivian, that's what you need to test. In here, I was focused on teaching you the mocking framework, but you combine the testing techniques to achieve coverage and test everything that you should test, and you use mocks, right? So definitely, I would test, you know, an empty list, and a list with 1 element, and a list with many elements. Let me see. Great, great. So what I'm gonna do now, I'm gonna stop sharing my screen for a second. I'm gonna find the skeleton in my machine, and I will repeat the process in the same way that's gonna happen in the exam. Just 1 second. I think I can share my screen now. You're seeing my IntelliJ again, right? So if you unzip the skeleton and you just open it in IntelliJ, it knows what to do. What may happen is, for some crazy circumstances, maybe IntelliJ wasn't fully able to download the dependencies. Maybe your internet was a bit shaky at that time. So if you're typing Mockito here and you do dots, and IntelliJ doesn't know how to continue, and IntelliJ cannot add this import here, it's because the dependency is not there. The usually fix for this is you go here to the left part, you click at the pom.xml file, which is the file that contains all the dependencies of the project. It definitely contains Mockito. Yeah. Right click at the pom. Can you hear me? Great. So maybe it's just with you, Nico. So if you're facing some problems, for example, not finding Mockito, that can happen, right? Right click at the POM, then go to Maven, and then re-import. So once you click at re-import, Maven will do all the magic to make sure all the dependencies are available to you. And hopefully Mockito will be available now. So this is a pretty standard IntelliJ project. And that should work. And this usually fixes 99% of the problems. Yeah. So what is going to happen in the exam is you have this skeleton, and I'm going to give you a testing question, right? A domain testing question or a mock question, the procedure is the same. So let's suppose you are in the mock exercise, and we are going to give you something like this. Yeah. Definitely, the exercise is a bit better structured there, and it's something like this. Create a, let me just do this change right now because it will then look more like the exam. So it's going to look like this. I'm going to give you some instructions. And then I'm going to give you the different classes. And all you need to do is copy those to your IntelliJ. So this first one is called invoice filter. So I'm going to come to my IntelliJ, source main Java, command N, so new, Java class, same name, okay, invoice filter. Pay attention to typos, okay? And then you basically copy the entire content to this file. So I selected Command C, and I pasted it here. Yeah. At the beginning, it doesn't compile, of course, because we have to copy everything. So don't be afraid if you see some compilation errors. We have to copy everything. The second one is issued invoices. Oops, I typed the wrong name here. So it should be issued invoices. I'll fix this in a second. So I create a class with the same name, issued invoices. And same thing, I copy the content. For this exercise, I see that I'm missing the invoice class, right? Which is also important. So let me fix this real quick in the exercise. In the exam, of course, this is battle tested already. So it is going to appear like this. So let me just fix this first. Issued invoices. And then the same thing for the invoice. Right? Great. Let me see. So everything fixed here, everything fixed there. So you just give IntelliJ a few seconds because whenever you copy new stuff, IntelliJ needs to find out what to recompile. A good tip for you is once you copied everything, go to the build menu and then rebuild project. Okay, IntelliJ will delete everything and will recompile everything. So that's the best way to know if things are working. Okay. Nice. So then I see that I don't really have any compilation issues. I'm ready for the question. So in Web Lab, you know, you don't have to do anything in the solution tab. You can go to the test tab. And basically what you have in here is basically the same you have in this U test. Yeah. I give some imports for you. So maybe if you want, you can also copy this. So invoice filter test, same name I'm going to give here. But now pay attention in the test package, okay? Invoice filter test. That pop-up won't appear to you because you're not using Git. So I just pasted my test and I'm ready. So let's just do anything here just to see if it works. So I'm going to create the invoice filter class. It needs these issued invoices. I will create a mock. Yeah, oops. Capital I, great. I will teach my mock to do something. I don't know, when issued invoices dot all, then return one invoice. Yeah. You see, whenever it's red, it means IntelliJ cannot import it. I just do Control Enter and I select which one to import. This arrays.slist is a very good one for you to know, okay? Because if you're dealing with lists, this becomes quite handy. I just need to create this invoice now. So new invoice. It receives a customer and a value. And then I just call the method that I want. Yeah, this returns invoices. What does it do that I don't remember? It gets all invoices that are smaller than 100. So let's just create 2 invoices, okay? So we make this really real. Yeah. I get the list back and then I can do the assertions. I can use assert.j. Yeah, so I'm going to use assert that invoices contains inv1. Let me even see if IntelliJ has a more specific. Yes, contains exactly inv1. So then assert.j is really smart. If it's different than just invoice1, it's going to fail. What I do, I run in my local machine first to see if it works. And you know, that's what I suggest you to do. Make sure everything works in your machine first. It didn't pass. Let me see if I read the implementation correctly. It removes the ones that are smaller than 100. No, it stays with the ones that are smaller than 100. So this means I expect for invoice number 2. So these are the type of mistakes I can imagine you doing during the exam. And you know, you improve, you run your tests again. At some point, it is going to pass. Great. Then what you do is you just copy everything. And you paste it in your web lab. So for me, because I have this teacher's view, I have to go to submission. You don't have to do this. I go to the test tab, I paste everything, right? I save, and then I click here, your test. Web lab will compile your code, will run your code. And if it says done, test score 1-1, that means you had one test and one test passes. If you make some mistake, so let's suppose you write some Java code that doesn't compile and you run, then you see status running failure, and this is bad, right? This means web lab couldn't compile your stuff. And that's probably a mistake like this, yeah? You didn't copy correctly from IntelliJ to here. Then you fix the issue, you save, you run again, just to make sure everything works. And at some point it's gonna work, and then you're done. You just go to the next one. Something to pay attention to, I don't have packages here. Yeah, it is very common to have packages in your programs to give some logical separation to things. But in here, just put everything without a package. So directly inside of this Java folder, yeah? Let's see. So this .all method, it's not from Mockito, okay? So this all is from our code, right? So as a developer, I create this interface, and this interface has this all method. And that's the method I want to mock. That's the method I want to teach the mock to do something. So that's why I do .all here. This method could have any other name. It depends on what the developer wants to do here. So it could be, for example, some developers are more verbose, and it could be something like get all invoices. So I renamed using IntelliJ, so it renamed everywhere, which means also here. Yeah. So I'm teaching my mock that when get all invoices, which previously was called all, to return this list. Yeah. Of course, please do not rename stuff during the exam. The classes that I give to you, you should not change them. If you change them, Web Lab will get completely confused and your code won't work. Why is the invoice not mocked? That is an excellent question. A very pragmatic question, actually. So could I have mocked the invoice? Yes, right? Instead of creating a real invoice here, I could simply do something like this. Yeah, so I also mock the invoice. If I mock this invoice, I would have to mock also the value that is inside of this object, right? So that this invoice is like the previous one that is 150. And that's something you can also do. However, as a developer, the trade-off that I do is it easy to create the class? If it's easy, I just create the class itself. I don't mock. And this is usually a true thing when you're talking about these entity objects that represent something in your system, like an invoice or product or user. Usually those type of classes are easy to create, and then I tend not to mock them. Of course, in real life, exceptions happen because maybe this invoice class is really complex, like really huge. And then you decide to mock it. But my suggestion for you is only mock the dependencies themselves, like things you pass in the constructor. So in the case of the filter, this is the only dependency you're passing in the constructor. That is the thing I would mock. Yeah. Great. Also, a nice thing for you to do is to remove imports that are not used, right? So you can optimize the imports in IntelliJ. If you go to the import that you're not using, to the huge list, you can Control-Enter, optimize imports, so that you only deliver what really matters, right? It makes your code less verbose. Can I solve one more example like this? That was a private message to me. Can I solve one more example like this from MATLAB? Let me see if we have another one. Let's go for this order delivery batch. So I would do the same thing. I would copy the code. So order delivery batch, that's the name of the class I'm gonna create. So I just create it and I copy it from here. Nothing compiles, that's still okay. I still need to copy everything. Then I have another one that is called book in here. That's what I'm gonna do. So class book. I didn't fully separate, but you can see that that's another one, right? So delivery start process. Let me create this one as well. And I copy. So you see, this is mechanical work. And I think it's only prone to small typos, you know? Oops. Oops, what's going on? What's the name of the last one? Orders. So I copied everything. Let's see. You see, this is something to pay attention. I started to copy things, and IntelliJ tries to be really smart. So when I copied this exercise, IntelliJ was looking for a book class, and it imported from java.awt. That's not the class you want, so you delete it. So that may be also a common fix for tomorrow. Make sure IntelliJ is not adding extra imports, because it tries to be really smart before you copy everything. So let me do the same tip that I said to you before: build, rebuild project, to see if it stops complaining. Yeah, no complaints from IntelliJ, everything compiles. And then I can start to solve the problem. And if I want to, I can even copy the test code that I give to you. So let me also create the same class with the same name. This is not going to appear to you. I'm using Git, and you're not using Git. Yeah. And then I have the skeleton here. I then just write my tests. So order delivery batch, that's the class I want to test. What does it depend on? It depends on a list of orders and a list of delivery, right? And I just repeat the process. Right, I create two mocks, one for each class here. You see, again, IntelliJ shortcuts, just the initials of the class, and then IntelliJ complements for me. And I keep going. Do you need me to complete this up to the end, or you got the spirit and you can then compare what you do with the answer? Right, so yeah, maybe we can look at the answer that gives us everything that we need. Let me copy this to IntelliJ. So what I was doing before, same thing, just declaring the mocks. I decided to do this in the fields to make it more elegant, make my test method a bit shorter. I create two books because from the production class, I learned that that's what I need to teach my mock to do, to return a list of orders, right? So that's the method I need to mock, paid but not delivered. What do you do in practice? Or if you need some hints, just go to the implementation of the method. So what does it do? It returns a collection of books. So you know what this method is about, right? So that's what we do. We create a collection of books. So Lord of the Rings, Harry Potter, I use the when, I run the program, and I do the verifications, right? So I verify that the liver receives the first book and receives the second book. And in here, I decided to show you the verify no more interactions feature, right? That can be one option, but that would be totally fine if you just do like this, yeah? Note that you don't have to put ×1 because that's the default value. If you just do like this, behind the scenes, Mockito does ×1 for you. Yeah. Would the exam, the questions about mocks, are they similar to the ones you're going to see in the exam? Definitely. So if you really got the spirit of solving those questions, you are going to do very well tomorrow. What kind of questions can I expect from the web testing part? Questions that are similar to the ones you see also in the practice. Right? Questions related to discussing how you would write tests for this in an abstract level. Right? Maybe related to testability, right? How easy it is to write a test for this, etc. We also discussed state objects there, but we're not going to ask you to apply state objects. So you need to understand what state objects are, and that should be enough. There was a question on accessibility, so reason about accessibility. So again, very similar to what you're seeing here, yeah? So we will not ask you questions from things we did not do live in the lecture. So the state objects, we discussed what it is, but we didn't really implement lots of them in the course, so I'm not going to really ask you to do state objects. There was a question about state machines before, right? But I don't remember what this question was about, and this chat is very long, so if you want to rephrase your question about state machine testing, you can do it now. The same skeleton, okay? The same skeleton that you use for the midterm works for the exam. But if you just join it now, maybe you should watch the video because I showed how you could import stuff to WebLab. I also saw a question about the for each loop. How do you do that? Just represent the for each loop as a single decision block. So something as simple as this definitely works. For, and then your elementing list here. The body of the for. Then you just put an arrow, right? So if this is true, it goes to the body of the for. At some point, your code continues. You basically then connect your loop. For some reason, again, I don't have my ask button, so it's been really hard to, yeah. Right, so this is a branch node. So it has a true branch and a false branch. And at some point, the body of the for has to come back to the loop, right? So something like this should work. Yeah, you don't have to do things that are more complicated than this. No need for it. Then one question about the structural testing. What do I expect? That's a good question. Let me find an example that is good. I'm trying to find the same example that I use in the midterm mock because that exemplifies very well. Yeah, so I give you this piece of code, right? Delete white space. And the first thing you do is domain testing, right? So you basically focus on the documentation and you derive tests. And that is great, right? So that's your first part. You derive tests out of the specification. Great. Hopefully, because you did such a good job, the partitions that you devised during the domain testing already achieve a very high coverage in your code. However, what happens in real life is sometimes the implementation changes a little bit, right? You have some extra stuff in the implementation that was not in the specification. And this example, this delete white space method has an example of this, which is this if statement. So this if statement makes sure that if you don't delete anything, suppose a string that doesn't have white spaces, the reference is the same. So the method returns the same string. Yeah, it doesn't allocate a new string, which happens if a white space is deleted. So this is a behavior that is not in the specification. The specification doesn't say if we don't remove white spaces, we have to return the same instance. So this is what I expect you to do in the structural testing, to look at the source code now and see if there are test cases that you couldn't see from the specification, and then you decide to write one more. And in the midterm, I even wrote one extra test for this, right? Keep the same reference. And I use the same as, which in AssertJ is checking the reference, the internal reference, the pointer of the string. Yeah. So this is what I expect you when doing structural testing, that after you do the domain testing, you then go to the code and you see if there are extra tests to be done. In the midterm, a lot of the answers were, I did not see anything else because my partitions were already very good. But that gave me confidence that my testing was very good. So this is the type of answer that can happen. Maybe you did such a rigorous job in the specification and the documentation was also very good that you don't see anything else to test. And then that's your answer, right? I did structural testing, but I did not see any other tests to do besides the ones I had before. And the question, so Costas is also asking me for a place where you would have to achieve MCDC coverage. Great question. We didn't talk so much about MCDC besides what we did in the structural testing lecture. But there is no big difference. So let's say you see this if in the code or something like that. And for some crazy reason, this if was not really represented in the documentation, right? So you only observe this in the implementation itself. And then as a tester, you are focused and you want to achieve 100% MCDC here. So then what you do is you get A, you get B, and you repeat the process that we discussed in that lecture. Maybe in an Excel spreadsheet, that gets better. So, but I also think we did a nice job in the video, so maybe watching the video is better than me doing here now. So you have the A and B, and then you basically build the table, right? The same way you learn in reason and logic, maybe if you don't remember. So for the last variable, you do true, false, so you keep changing one by one. Then when you go one to the left, you do 2 each time. If you had one more, then you would do 4 each time, so power of 2. So these are the 4 combinations, and then you apply the procedure we discussed to do MCDC, right? At the end, you will come up with a list of tests that you need to do. There are 2 variables in here, so this means you would need 3 tests. or something like that, then based on these 3 tests, you know what test to do, right? A test that, let's say, makes A to be true and B to be true. Another test that makes A to be true and B to be false. So that's how you combine MCDC and testing. You just look at the condition, you analyze the condition, you derive the tests, the smallest set of tests you need to exercise that condition in 100% MCDC, and you write the tests, right? You just find test cases that makes A to be true and test cases that makes A to be false, right? If it's like the condition is like this, if you want to make A to be true in test 1, then A can be like 50, right? This would make this to be true. Folks, we are definitely way past 6:30, and I'm just here because you're still asking questions, okay? But feel free to leave at some point. My wife is laughing at me because she says I'm torturing you because of this 1.5 hours of Q&A. So let me see this, maybe last question. If we find a new case to test during structural testing, should we answer in the structural testing part saying marginal testing? Yeah, great question. So let's suppose you do domain testing and for some reason you forgot a partition or you couldn't see a partition and you only saw this when you did structural testing. You can write it there. So you can definitely say, well, in the structural testing, I found this partition. Yeah. I have seen a little bit of both in the midterm. Like some people going back to the first exercise and then making the partitions better. And then in the structural testing part, they said this partition came after me doing some structural testing. So that is totally fine by me. Yeah. So in a way, some exercises have clear partitions that you can only see from structural testing. And that's what I want to see indicated in your answer, right? So if your exercise has a partition that can only be seen when you do structural testing, which is the case of this one in the midterm, right? So this was not really represented in the structure, in the documentation. That's what I expect to see there. Yeah? So what I'm saying is, we know the partitions that you have to find, and we expect you to find those partitions, right? By means of domain testing plus structural testing. That's how it happens in real life. You combine both. So if at the end of using both, you find all the partitions, you are fine. So I just reached the end of the chat. Any final question? I saw many questions. Maybe that's the last thing for me to say today. I will make the recording available right now. But there was a question that appeared many times, if I can say a few words about the structure of the exam. I don't think I can say much about this without really telling you what is in the exam. So in a sense, I cannot fully answer this. But what I can tell you is if you practice everything that is available for you here, you are going to be fine. So if I were you, I would focus on mastering these type of exercises. Yeah. So I think that's the best I can give you in terms of answers of how this looks like. Yeah. Thanks for the remark. I'm really happy you enjoyed the course. So tomorrow it starts at 9. So at 9 a.m. WebLab will make things available for you. If you have questions, open the questions via the discussions feature. If for some reason you cannot enroll in WebLab, which means you don't have access to the discussions feature, email me. And please pay attention to the Brightspace announcements. If I need for some reason to make a public announcement, I will do this via Brightspace. So make sure you have your notifications on for Brightspace messages. But that only in worst case scenario, probably, that I hope it won't happen. then I'll talk to you tomorrow. Bye, folks. Enjoy your dinner. I'm really happy you like it. Bye-bye.